Next week. Live now. All right. So, okay. So remind me, we're doing 5.3, which is partial fractions, right? I probably shouldn't use green. I'll pick a darker color here.
Well, look how blurry that is.
Yeah, it's seriously blurry. Now the question is.
I'm not wearing glasses. Yeah, what?
Focus. Focus. I don't know. It'll. There we go. There we go. So remind me, what did we talk about yesterday with regards to section 5.3? We did case number 1.
Partial fractions.
We're doing partial fractions. We're continuing on from where we left off yesterday.
Linear factors.
Yeah. So non-repeated linear factors. That's what we did yesterday. Correct? Okay. So now, this time, we're going to do
I've never stood on
case number 2. Case number 2, which is repeated linear factors. Okay?
What's the first one? Non-what?
Non-repeated linear factors. Okay? This time we're going to do repeated linear factors. Okay? Question?
Your stream on YouTube shows unavailable, so it might be just like recording.
It takes a while, I think, sometimes you have to wait.
Oh, you would know till it goes.
Yes, I watch it every day.
All right, well, I'm glad I got such great
I
fans.
can't see.
I could see how often you guys listen. All right. So non-repeated linear factors, now we're going to do repeated linear factors, okay? So there's a difference here, okay?
Wait, I thought we did linear factors last
Yeah,
time.
last time they were not repeated though.
Oh.
This time they're going to be repeated. Okay? So let's say that I say find the partial fractions. And this time I'm not going to make you factor it cubed. Okay? So you can see here, because I've got the 3 here, these are repeated linear factors, right? I've got x minus 1 3 times. Correct?
Yeah.
Okay? Okay, so this is an example of case number 2. Okay? So, and it was nice that I already factored it, so we didn't have to factor it, right? So, based on case number 1, what do you think we would do to break up this into multiple factors?
So we need to do 3 different fractions.
So at least 3 different factors. The 3 different fractions would be what?
So x minus 1.
So x would be 1 factor.
X minus 1.
X minus 1.
X plus 1.
Minus 1.
And then we're going to go, okay, so here's where this is different. We're going to do x minus 1 squared, and we're going to go x minus 1 cubed. Okay? Because it's a repeated linear factor, and this is the technique that we use to solve those. And of course, we're adding them all together.
Is the original a cube?
Yeah,
X
the original
minus
cube,
1?
not squared, yeah.
It's cubed. Sorry, that was a 3. If you thought it was a 2, it was a 3 all along. Okay? Does that make sense? Okay. Now, what do you think we're supposed to put in the numerator?
A, B, C.
A, B, C, and D. Okay? Now, the question is, maybe I should give myself a little bit more room here. I'm going to slide this over. I've got A over X, right? Okay? Now, this is already the common denominator, correct? What do I need to multiply this by, the X by, to get this common denominator? X minus 1 cubed and X minus 1 cubed, okay? What do I got to multiply this one by to get this? X and X minus 1 squared, right? X and X minus 1 squared. And this one?
X minus 1x.
X and X minus 1. X minus 1. And this one? Plain old X. Okay? All right, so we know these are repeated linear factors because this is repeated, correct?
Yeah.
Okay? So now, it's just algebra from here on, right?
It's been out here something.
Yeah. So you know what's funny is I remember doing a physics class in college, and I said, "Oh, it's just calculus from there." And I was like, "Man, something's happened here. This is not." Anyway. All right. So what do we do next here? Distribute, right? So this one's going to be a little bit hard, right? So let's just FOIL out. In fact, let me rewrite this as a times x minus 1 times x minus 1 squared. Okay? So can you help me do that, Nate?
Maybe.
Okay, so if I distribute this, I'm going to get
ax minus a1.
minus a, okay?
I'll just
And if I FOIL that out, I'm going to get
ax.
no, just this piece. Only care about that piece.
Oh, x minus 1. Oh, x
X
squared
squared
minus x,
minus 2x
or minus 2x minus 1,
plus 1.
or plus 1.
Okay? And then I'm going to ask Bailey, can you multiply these two together and then multiply those two together? Plus bx times x squared. Just this piece here.
Yeah, that's what it is. Oh, x squared minus 2b.
2x. Forget the b for a minute. We're not doing the b yet.
2x
Plus 1, right? And then,
Couldn't we just do that to do CX and then?
why don't you do that one?
I can just do my head if you want me
Because
to.
that one's easy. right?
CX,
Cx,
x squared.
cx squared.
Oh, wait. Oh.
I thought you were going to do that all in one step.
What I thought was we were just doing x squared minus 2x plus
No,
1
we're doing this
on
one
every
now.
single section. I was like, why are we like?
Yeah, no, we're.
Oh, I can do that if you want me to.
Yep, I do want you to.
CX squared minus C,
Cx
CX.
plus, here, you can do the last one.
Yeah. You want me to do DX.
Dx. All over my denominator of x times x minus 1 cubed. Now, at this point, we've got the common denominator, so I'm not going to worry about the common denominator. All I'm going to worry about is the numerator from here on, okay? Yes.
We're not gonna worry about factoring it out more or
Well,
distributing.
now we got to distribute. That's the next thing. Well, this is going to be fun, right? Jonathan,
Never mind, I figured it out.
you figured it out. Okay, Spencer, do you want to start foiling this out? Ax times x squared.
That's ax squared,
Ax
ax cubed.
Ax times negative 2x.
2ax
Negative
squared.
2ax squared. Ax times 1
That's ax
plus ax. Now we're going to do these.
minus ax
Minus
squared
ax squared
plus 2ax
plus 2ax
minus a.
minus a. Okay? We'll move on to somebody else for this.
Wait, I have a question. So that, for the A, why did you first split up the cube into a square root? Or not?
Like this?
Yeah.
You asked
yeah,
me why I
did
did
you
that?
split that up?
Because I knew I could FOIL that out fairly easily to get that, and I knew that I could do that, and I just used to break it up into steps.
It distribute you.
Because unlike Andrew here, I can do that all in my head in one step.
I can teach
Wait,
you
is
the
that
ways.
Say that again? Oh, I didn't hear. I thought you said something.
I didn't say.
Okay. All right, so do you want to take over this part here? We're going to multiply this times each one of those,
No, thanks.
please?
No.
This is not too bad.
This is ethically wrong to make us do this.
I'm only trying to teach you.
Yeah, okay, fine, I'll do it. Bx cubed,
Bx cubed
b
minus
times 2x
times
squared.
2bx squared
Yeah, squared. And then bx.
plus bx. And then I'll just rewrite this, plus cx squared minus cx plus dx. And I'm going to ignore the denominator now because now all we care about is the numerator, okay? All right, so now, okay, look at this. So we're good, okay? So here's what we gotta do. We need to come up with an x cubed equation. And we need to come up with an x squared equation, and we need to come up with an x equation, and we need to come up with a number equation. You thought 3 equations and 3 unknowns was bad. How about 4 or 5? Okay, so let's pick on
Let's find the domain of it.
Ethan. Ethan, can you come up with an x cubed equation out of this big mess? Oh, you guys aren't telling me that I'm off camera. What is your problem? If you guys were doing the game last night, you would have missed all the baskets.
I noticed I missed some points.
Okay? All right, Ethan, what do you think? Can you come up with an x cubed equation? So we've got an a, so that's 1, right? Plus b. Is that it?
Yeah.
Okay, what does that equal?
C.
It's not equal c.
A plus B. Oh,
This is my original equation here. What's the coefficient on the x cubed term?
Oh, 1.
It's 1?
Wait. Oh, 0, my bad.
That's a big fat 0. Do you see that, everybody? There's no x cubed. I could have written plus 0x cubed if you wanted me to.
Oh, okay, so it's.
Oh, you just dirty.
Yeah, there we go.
Magic.
Yeah, my bad.
Tricky. Tricky.
Oh my gosh.
You guys even know that song? Who
Yes.
sings it?
DMC. or-
Run DMC. There you go.
I think he deserves extra credit on that one.
He definitely deserves extra
I got you, dude. I got you, bro.
All right, let's do the x squared equation. It must be Christian's turn to do the x squared equation. How do I do that?
Okay, so that should be negative 2a.
Negative 2a
And negative a.
minus a, so that, I'm gonna make that negative 3a, right?
Wait, yeah.
Okay,
And then negative 2b, minus 2b
minus 2b
plus c,
plus c
and that's it.
equals,
Equals 0.
Nope.
No.
X.
X to cube.
Which
One
one?
of those?
It's one of those.
The one.
You sure?
Yeah,
You really sure?
100%.
100%, that's good. That makes me happier, 100%. Why is it 1?
Because it's X
The
squared plus
coefficient of
1.
x squared is.
Because the coefficient of the x squared is a big fat 1 there, right?
Then 1 plus 1's 2. 1's pretty sweet.
So if there was a 3
That's
up
my
there,
paper term, that's my constant term.
Yeah.
there's 3 up there.
Okay, so Julia, you must be next.
Okay,
What is the x term?
okay, so A,
Here, should I pick another color?
sure,
Pick another color here, red. A
plus 2A,
plus 2a becomes 3a, okay?
plus B,
Plus b
minus C,
minus c
plus E,
plus d equals
equals 0.
0. How did you get a 0?
Because, it's on the original.
Because I could write a
Yep.
plus 0x there if I wanted to.
And we're just doing the numerator.
All right? And then finally, Dino, can you do the last one? Oh, I forgot to circle the red one here. Negative a. What color do I have left? Oh, I got 2 blues today. Purple. Negative a, right? Equals positive 1. Well, that was nice, because that just made that positive a equals negative 1. All right, so that was lucky.
Positive equals negative 1.
Yeah, negative 1.
That's kind of a.
Positive a equals negative 1. So at this point, I know that this first term here, right here, I guess, negative 1 over x, right? That's the first term. Okay? Then what, Dino? Since you got off the hook so easy, what should you do next?
How do you know that?
How do you know that negative a equals negative 1? Because I've only got, this one term here, and it has to equal the constant term, which is that number right there.
So then you just switch it to negative 1. Yeah, I'm asking, how do you get negative 1 over x?
Oh, because remember, it's kind of hard to tell. Remember, when I set up these terms, I had a over x plus b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed.
Yeah. And then
So now I've plugged in the negative 1 here to get that
at a.
first case. So I'm just trying to write this down as I go.
I get it.
Okay? So now, Berkeley, what should I do next?
Wait, so how did you get that?
How do I get what?
Negative 1 over x.
Because I plugged the a equals negative 1 into that equation right there.
Okay.
Okay? So since a is negative 1,
Then over x.
I could probably substitute it into this equation here, right? Ooh, that would be nice.
So b is negative 1.
So b is negative 1?
It's positive 1, sorry. Because I didn't see that.
Yes, negative 1 plus b equals 0, so add 1. So b equals 1, correct?
Yes.
Okay, so now b equals 1 here, so I'm going to add plus b over x minus 1. Okay, so I've got these first two terms are done.
Okay, did you say b is,
So did you do
What?
1 over x minus 1?
What'd you say?
Would you do 1 over x minus 1?
so
Oh, sorry, 1 over x minus 1. That's what I meant. Yeah, 1 over x minus 1. That's what I meant to put. Okay? All right, so now we got to pick on Stephen, because clearly he's not paying attention because he's texting somebody on his phone. Okay, so what do we do next?
I know exactly what's doing next.
That's good. Good thing you weren't texting.
Yes, good thing. So what did we just do?
I don't know.
he was asking why I was phone.
We found out that a equals negative 1, and we found out that b equals 1.
Okay, so we just need to find C.
So how do we find c?
Same way, just plug it in.
We're going to use this equation here, right?
Yeah.
So we're going to get what?
Negative 3 times negative 1
Negative 1
minus
minus.
2 times 1.
You sure about that?
I'm pretty sure.
Pretty sure. Okay,
Let's see.
plus c. It's a good thing you got the phone a friend thing going on, or you'd be in trouble. If only you could do that during the test, right? Okay, why does it equal 1?
Because negative.
We're plugging it into this equation right here.
Yeah.
Okay? So this is positive 3 minus 2 is positive 1.
What did you say? I didn't hear you.
Positive 3 minus 2
1.
is 1. So how do I get rid of that?
Just subtract it.
Subtract 1.
C is equal to 0.
C equals 0. So now this part is plus 0 over x minus 1 squared. I really don't need to put that, but I'll do it anyway.
It's a big problem.
Okay? And then finally, we're going to pick on Jonathan.
Then you just plug it into the,
Now we get to plug all of these into where?
so
Into here, right?
negative 3 plus 1.
Okay, so negative 3 times negative 1, right?
Or it's positive 3 times.
Positive 3 times negative 1. Yeah, I'm looking at the wrong equation. Positive 3 times negative 1 plus b, which is
1.
plus 1 minus
0.
0 plus d equals 0. So this becomes negative 3 plus 1,
So it's negative 2.
negative 2. So if I add 2 to both sides, d equals
I know.
b equals 2. So my final fraction is, when I put my answer right here,
2 over x minus 1.
2 over x minus 1 cubed. Those are your partial fractions. Clearly, you don't need to include that in there, but whatever. Okay?
That's it.
That's it. All there is to that.
So for the
20
answer, we would
minutes.
just circle.
That's all I have to say about that as far as compensate. Niels?
So tell me if I can do this or not. In my mind, I want to simplify so I don't have 4 unknowns. If you were to distribute the denominator at the very beginning, would that work?
That would make your life so much more miserable.
And how?
Yeah, don't do that.
So we would just circle that and remove it.
Circle that. Yeah, I probably wouldn't even write that one down. I put it in there just to know, just to show you that it's part of it. It's not wrong.
So our final answer is -1 over x plus 1 over x.
Negative 1 over x plus 1 over x minus 1 plus 2 over x minus 1 cubed. Those are your partial fractions. Okay?
He says, is there any way to guess that?
Just a lucky guess.
I'll tell you tomorrow, dude.
You know, they say that if you take a monkey and just put him in front of a typewriter, that, you know, in a certain amount of time, he'll be able to type out Shakespeare's, you know.
So what you're saying is I stare at the test long enough, it'll give you the answers?
Yeah, but you only get an hour. Okay? It's gonna be a fun test, right? We got logarithms, we got partial fractions.
You're not gonna make it.
Yeah.
So can we just have one question of partial fractions, since we only have an hour?
Yeah, that's just 20
20
minutes.
And you messed up a couple times.
Unless you want to give us just that for the test.
Or a bonus.
Just give us like one of those.
Yeah,
Okay,
yeah,
that's a good idea.
that'd be fine. I mean, you get 10 points.
I would try even harder if it was bonus.
Do you want me, I could put like 20 problems on there and then give you unlimited statistics on it. What do you think of that?
No, testing centers suck.
Stresses me out.
Seriously. All right.
Just make it a take home.
It's time to move on to case number 3.
Wow, love that.
Unlimited time.
Base 3?
Case number 3. Okay.
How many pieces are there?
Case number 3. It has, we're going to use non-repeated quadratic factors. Aha. Oh, we got a picture even. Feel like Picasso up here. Okay?
No, it doesn't look good at all.
People taking pictures of my artwork here. That's good. All right, so let's do another problem. Case number 3, and I'll show you what the trick is. The trick is always at the beginning. Hopefully you'll see these get kind of repetitive after a while.
How many cases
But
are
the
there?
problem is there's 4 cases. Aren't you glad we started this yesterday?
How many cases are there?
4.
Did he just say that? He
No,
wasn't
you're-
listening.
You're good, you're good.
Sorry. He was talking to me about the street, but I didn't listen. I'm sorry.
All right, okay. So let's do this one. Fine. Be partial fractions. Okay, this time we've got 2x squared minus x plus 4 all over x cubed plus 4x. Okay, that wasn't nice. Well, this one's not too bad though. All right, who haven't I picked on? It must be, I have to pick on Steven again if you need. You're not going to pass the test, seriously, if you're texting during class, okay? I can let you just fail, but I'm trying to keep you engaged, okay? So please put that away. Everybody, please put your phone away. This is hard enough, but if you're only paying half attention, there ain't no way you're going to pass the test, okay? So I like to have fun in here, you know, I like to be nice, but we've got to really focus, okay? Let's go with Niels, okay? What do you think? What's the first step?
Well, to make it look like previous ones, would you pull an x out of the denominator?
Yes, we can factor this. X times
X x squared plus 4.
X squared plus 4. Can I factor that anymore?
Yes, sir.
No. Can't. Okay? So I've rewritten this as this, okay? Now, if we were doing this in the past, what would we break those up into? Break it up into two fractions. One would be x, thank you, Angel, and the other one is what? X squared plus 4. Okay? So far, so good. Nothing's too different. Okay? I've got a linear fraction, and I have a quadratic fraction, right? Okay? With the linear fraction, what would I do? I've done this in the past for the numerator. I'm going to put an a up here, plus, okay? This is the difference. This is case number 3. This is why it's different than the other two cases. This time, I'm going to put bx plus c in the numerator. Okay? Why? Because it's case number 3, and that's what you do.
How do you know? Can we just need to memorize what case it is?
Yes,
And then
yes.
be like, oh, this case.
Yeah, that's why you need to memorize these cases.
Is it always bx?
If you have it's non-repeated, and it's a quadratic factor. So I've got a linear factor, and I have a quadratic factor. Okay?
So if that was like x, like cubed plus 4, would you still do bx plus c? Or we're not doing something
We're
like
not
that?
doing that.
Okay.
What do you think, but I will ask you this, what do you think case number 4 is going to be?
Repeated.
Repeated quadratic. That's going to be fun. Okay? I'll have to put that on the quiz tomorrow. Oh, there's no quiz tomorrow.
It's a test.
Oh, I forgot we have a test every Thursday.
All right, so now, let's see, have I picked on Christian?
Yeah.
I have? Oh, it must be time to pick on you again. Right after Berkeley's question.
Okay.
So why is it bx plus c?
Because it's case number 3, and that's what you do.
How do I know it's case number 3?
How do you know it's case number 3? Who can answer that
it's the
question?
non-repeated quadratic.
If it's non-repeated, and I have a quadratic factor.
Repeated meaning that makes sense.
It doesn't repeat.
So if there was a squared on the outside of the parentheses, then it would be case 2.
Yeah, if there was a 2 here, then it would be a repeated quadratic factor, and then it would be case number 4.
Oh.
Guess where we're going next?
Oh. And if it was cubed, then it would be case 2.
If what was cubed?
The parentheses, or like, you
If
know,
this was cubed,
yeah.
ain't doing it. This is hard enough. You want to make it harder?
No.
We're only doing 4 cases. That's it. We're not gonna
But
make
the
it.
other one
This
had
is hard
a,
enough.
the other one had a cubed outside of it.
But if it had a cube here, what is that? That's a repeated linear factor. This one we could do. This is
Okay.
a good test question.
And if that squared was taken out and there was a cubed on out the outside of the parentheses, then it would be a
If
2.
the squared was out and this was a cube, then it would be case number 2. That's correct. Okay?
That's right.
We're good? Okay, let's put it back the way it was. Okay? Question? Angel?
I think I'm trying to understand the exact same thing. So first thing you do when you see that, it says find partial fractions, you just factor out the bottom portion as much as you can.
As much as you can, and then this is as much as we can, right? I can't reduce this anymore. I can't turn this into a linear factor.
And then what makes it a non-repeated one is when there's
It's
no.
because the x is like,
Or I'm just going based on the example.
So going back to Berkeley's question here, if I had left this as x cubed times x plus 4, this is linear. This is a linear repeated. It's repeated 3 times.
No matter what.
It's not because it's odd. 2 would also be repeated, right? Oh, yeah, this would be case 2.
And then what's
It's
case
in the
1?
front, it's in the front.
Case 1 is, that would be case 1 right
Yeah,
there.
yesterday it was just,
Non-repeated linear factors.
so there's no factors there.
So this would be case 1, this would be case 2.
Yeah.
This is case 3,
Did you write those?
and this would be case 4.
Oh, could we write that next to each one of the cases so we can see the difference, like, side by side?
What do you want me to write?
Like,
So it would just do an x next to the case one, and then.
So x times x minus 1, that would be an
Yeah,
example.
there you go. And then
This would be
cubed.
x squared times x minus
Yeah,
1.
there you go.
This would be x times x squared plus 1, because you can't factor that. Now, let me ask you a question. If I had to x times x squared minus 1,
That can be factored. it's not
that can be
just a-
factored, and that would become linear, correct? Case number 1. Case number 1,
So,
all right?
if you throw, well, what you're saying is if you square the 2x plus 1, that's case 4?
Say it again.
Okay, so that's case 4 right there, right?
This is case 4 right here.
Okay, that makes
Both of
sense.
those,
So these are an example, yeah.
And that's the denominator.
Yeah.
This is the denominator I'm talking about, yeah.
Does it matter what's on the numerator?
Does not matter what's on the numerator.
so for case 1, under it, you had a squared on that, the second x, would it still make it?
So that's a good question. Dino says, what if I put a squared on the first x, right?
No, I'm talking about the one in the parentheses. Like if it was just x, would it still be case 1?
If it was just this,
Yeah.
if it was just that, what case would it be?
Case 2.
Case 2 repeated, because this is repeated and this is repeated.
Oh,
This is case 2.
Should have lesson on that one.
We're having one. All right, here we go. So repeated quadratic factors. That's an example of a repeated quadratic factor.
But since they're not repeated, so it would be.
Okay? So those are your examples. Are we ready?
Yeah.
We never got through this whole thing, have we?
So like,
All right.
so the one has written.
So now let's go back to here. This looks terrible. I'm going to rewrite this as x times x squared plus 4. Okay? Okay, so what do we do next? I think we're going back to Christian.
Okay, so you're gonna take the denominator or whatever that was in
Okay?
make it equal to the one on the left, right?
Yeah, I need to multiply, yeah, so what do I multiply this by to get this?
X squared and 4.
Plus 4, x squared plus 4. And what do I multiply this by to get this?
X.
X and x. Okay? So can you distribute this,
The top one or the bottom?
this piece here?
Yes.
Okay?
So you get ax squared.
Ax squared
A4
plus 4a
plus,
plus
bx squared
bx squared
plus cx.
plus cx. Okay? And I'm not going to worry about my denominator anymore because now the denominators match and I only care about the numerators. Okay?
Right.
So then what? Bailey, it must be your turn again.
Factor in.
Okay, could we, I don't know if this is helpful, actually. I know I'm lost.
I can't hear you.
Can you give me a hint?
Can I give you a hint? Okay, so this is all done, right? So now I need to start making my 3 equations and 3 unknowns or whatever it works out to be. Okay, so what's my highest degree? I've got an x squared term, and I'm going to need what? An x, and I'm going to need a number or a constant term. Okay, so let's create an equation for the x squareds.
Okay, so it would just be a x squared.
So I'm going to drop the x squared and just say a plus b has to equal 2. You sure about that?
Yes.
Okay, good. Okay,
Wait, so what is it equal to?
Because the coefficient of 2 is.
coefficient of 2x squared right here. So this a plus that b has to equal that 2.
So then when we get to the x's, do we look at the x coefficient on the numerator?
Do you want to take it away?
Yeah.
Okay, what's the next one? What's the x?
Cx?
So cx,
C.
so I just need the c, correct?
C equals -1?
C equals -1, y -1.
Because it's a -1.
It's a -1 right there. Okay? -1x,
You
right?
flip it, the c is negative.
-1x?
Yeah.
Okay. Then, Spencer, what?
Then it's gonna be 4a equals 4.
4a equals 4, because it's that 4 and that 4a. Well, this one was way easier. than
It's
that.
way easier.
Would a equal 1?
Okay, so a would equal 1, right? Divide by 4. A equals 1, and c equals -1, and now I just got to find b. 1 plus b equals 2. That's why you should always write it down so you don't make mistakes like that. And, oh, actually, it wasn't a mistake. You're right. I thought it was. B equals 1. And so what are your partial fractions?
Ooh.
Kelly, take us away. No, don't trip at the finish line. You're at the finish line.
Okay, so it's gonna be, what is it? 1 over x
1 over x
plus,
plus
x plus -1 over,
x.
this is 1 times.
Where's, oh, just, we could write that as x minus 1, right?
Yes, x minus
Okay, over,
x squared plus 4.
Yeah.
okay, piece of cake.
So like b,
This is starting.
most of it, I just want to try to talk back. But get how we got a equals 1, c equals -1, b equals 1.
Okay.
Now I'm wondering where you got the.
So we're taking this c, oh, we're plugging it in right there. We're taking this a, we're plugging it in right here. And we're taking this b and we're plugging it in right there. Okay? You should all do your homework in colored pencils, right?
For real.
Okay, does that make sense?
Or a whiteboard.
Or a whiteboard. All right, so the problem is whiteboards erase too easily, all right? Okay, we ready for case number 4? Oh, I should have asked if you wanted to take a picture. It was too late, I already erased some of it.
It's on the screen. It's okay.
Okay, yeah, you can take a picture on YouTube. Okay? All right, so case number 4. All right, here we go. Oh, this is a good one. I like this one. Oh, you guys are in trouble now, all right? All right, so I've got here x to the 5th minus 3x squared plus 12x minus 1 all over x cubed over x squared plus x plus 1 times x squared plus 2 squared.
So that's case 4.
Definitely case 4.
Because there's one in the parentheses and one out of it.
I don't think we'll actually solve this one, but we'll set it up.
Why?
You'll see why.
It's dumb. It's dependent.
The answer keys are happening.
All right, so any volunteers want to start tackling this? Niels?
All right, so it looks like we're gonna be solving for 6 unknowns.
We've got 3, 4, 5, 6, right? Only 6, that's not bad.
But 3, I don't know, Chad, I got 6 right there.
Okay, explain how you got 6 out there, Niels.
Well, because we split the x.
So this is a repeated linear factor, correct?
Yeah.
So that's going to be something over x
Why
plus,
isn't it repeated quad?
why isn't it a repeated quadratic factor?
It's coming, dude. It's totally coming.
I could rewrite this as x times x times x, right?
Yeah.
That's a repeated linear factor. You see that? Okay, so the next repeated linear factor is
X.
x squared.
So I wouldn't put out x 3 times?
That's right. X squared, and the next one is x cubed.
Plus x cubed.
And then it's going to be, the next is the x squared plus x plus 1.
X squared plus x plus 1.
And then x squared plus 2,
and then x squared plus 2
and then x squared plus 2,
plus 2
parentheses squared.
And we've only just
So
begun.
finding the common denominator.
Okay, so what do I put up here?
A plus B,
B,
C,
C,
I know we have to do English in a math class.
D. Is that it?
E.
This is quadratic.
oh, so then it's going to be D
Plus
x plus
X plus E.
Okay, then F.
F.
When we get to F, I know.
Is that it?
That one also has X plus
I didn't know alphabet.
G,
and then H,
H,
X
X,
plus I.
plus I.
Oh, wait, I don't understand that. Oh, because.
Now we're
Can you have
talking.
different cases in one F?
This one, well, this is kind of a combination of case 2 and case 4.
Oh, okay.
I don't understand the, I get
There's
it.
one case.
I get the A, B, C, D. Do I just put a number in where the X's are?
What do you
There's
mean?
an S right?
Okay. Now, how many unknowns do we have? Too many. That's the right answer. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9.
Can we add one?
9 equations, 9 unknowns. How about that? That's what I'm talking about.
And only 35 minutes to
Let's
solve
just
it.
graph it.
35 minutes to solve it.
All right, let's bust it out.
Here comes the shortcut.
We can do it.
Okay? I'm not going to give you one that hard, but I'm glad, Niels, that you could set it up.
Thank you, Neil.
Okay? Just so you know. Good job, Niels. Good job, Niels. In real life, you can end up with a lot of unknowns. And that's when you start needing computers to solve these things, because this is a pain in the butt. Okay, this is actually going to be what was going to be called linear algebra. We are going to learn how to solve, but I don't think we're going to get above a, we might do a 4x4, but probably stick by 2x3s, because otherwise it just takes too long. Okay? But what I wanted to do is make sure you knew how to set that up. Okay? Now, maybe, are you recording me? Oh, you.
This is art. We should tell Steven that we're going to be tested on it. Steven's gone right now.
Yeah. All right. So,
Just curious, when is this like?
Oh. the book homework even did one. They put a cube here. That would be even better. Okay? Anyway, so I did want to make sure you knew how to set that up. I may put one of these on here, but I won't go up to the x to the 5th. But yeah, this is ugly.
Is there gonna be a combination of cases on the test?
Well, this is a combination of cases.
I know, but will,
Yeah, you could, this would be a combination of 2 and 4. That is possible, yes. Okay?
We're not gonna solve this right now, right?
We're not gonna solve this. Okay? But,
So I'm just guessing, like, every time you see an X on a denominator, that's where we put like another letter. So like, I understand the A, B, C, but then the X squared plus X plus 1. The D goes.
okay, so just to explain, these are essentially case 2, right?
Uh-huh.
This is case what? Case 3. And this is
Case 4.
case 4.
I get that.
So we threw them all together in one.
My question is like, every X in the denominator, would we just put a letter above that? So like X squared, we put a D, and then there's another X, we put an E. Like, I don't understand.
So the idea here is, yes, notice, what's the degree, so this is degree 1 on the denominator, what's the degree on the numerator?
1.
0.
0. Okay.
This is degree 2, what's my degree on the numerator? 1. This is, so when we're looking at this, whatever degree you have on the denominator, you put 1 degree less on the numerator. Does that make sense? So this is quadratic, so I'm going to go down one. This is quadratic, I'm going to go down one. This is quadratic repeated, so it's quadratic, I'm just going to go down one.
Okay.
Okay, so that's how it works. You could probably keep going into more cases, but we're going to stop at quadratic. We're not going to go into cubic factors. Okay. Cool. Aren't you glad? See how easy the teacher I am? Dana.
This for instance, on the test, like on the test, we have to be able to determine which cases.
Well, you'll have to in order to solve it. Yeah, you'll need to know which case it is. You can learn that quick, don't you?
Well,
Aren't you glad I introduced this yesterday?
I guess.
So in the book, I have another fraction on
I
it.
know, because they don't
I-
do cubic.
They write them back?
I don't like them, yeah.
The book was even harder than that.
Have you seen like the X's, the
Yeah.
I think to add on to his question,
We can't hear, and hopefully we can hear the question.
just to add on to his question, I think it's clarifying, are you gonna ask for us to say, write out, this is case one, this is case two? Because my brain
It's
will-
possible, but I doubt it because,
Because my brain will remember, I see that, I do this, I won't remember this is case one, this is case three. This is case four.
oh yeah, I don't think I'll ask that question, but yeah. Okay? All right. You ready to move on to the last section that we'll have on the test? Okay, that's 5.4.
It made sense once you gave us.
Yeah.
Now it's like, I can actually sit here and solve.
All right, well, I'm glad we're making progress. All right. This is 5.4. Systems of non-linear equations. Okay. So I'm going to say solve. What if I had x squared plus y squared equal 100? And 3x minus y equals 10. Okay? Where is it? Must be Nate's turn. First of all, first question, before we solve this, I just want to make sure we understand what's going on. Do you know what this is an equation of?
Oh, I didn't know that.
You didn't know that? Okay, Bailey do that. It's a circle of radius. No, it's okay. I was like, dang, your voice got really hard.
Yeah.
It's a circle of radius. Neither 50 nor 100. 10. Remember, that's r squared, right? The circle of radius 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go, that's good enough. A circle, okay? What is this, the equation of?
Triangle.
A line.
You're trying.
We don't know the equations of triangles in this class. Okay, it's a line, right? Line that has an intercept at, let's see, if I rewrote this as y equals
Negative 3x minus 10.
negative 3x minus 10, right? So I would go to minus 10 right here. I would rise negative 3, and I would run 1. So it's going to look like this, okay? Now the idea here is, where does this line equal that circle? 2 points, right? We need to figure out, hopefully, and I don't know if I drew it right, but hopefully it's either there and there.
Is it like?
We're gonna find out. In fact, we're gonna see how good my picture
It'd be 10 and 10, because.
Maybe, we'll
It should
see.
be a perfect circle.
We're gonna find out, okay? So we need to figure out what are these 2 points. Let's see how well I drew my picture. Okay? It could have, yeah, we'll see. Okay, so at any rate, let's go back to here. This is the way we had it, okay? So we've got a circle and a line, okay? The line is linear, but the circle clearly is nonlinear, correct? So, Hunter, how would you solve that?
Good question.
No idea? You got an idea, Berkeley?
Wait, I gotta think for a sec. Maybe. Well, negative 10, I think would be y.
Okay, so let's go back to this question. Two equations, two unknowns, you got two ways to solve it. What do we square?
Square the y.
Oh, yeah, do
Back up.
do that thing.
Two equations, two unknowns. In the past, there's two methods to solve. Substitution or elimination. Which do you think would be better? Substitution or elimination? Substitution would be much easier because I could get a y equals, which I just did and then erased. Okay, y equals negative 3x plus 10, correct?
Yeah.
Okay, now I'm going to substitute that into here.
Oh, that is easier.
Okay, so do you want to take that away, Hunter?
So x squared.
X squared plus.
Yeah, that's wrong.
Is that wrong?
It's,
It might be because I was hurried.
it's
Okay.
y equals positive 3x minus 10.
If I subtract 3x,
Yeah, 'cause you have
negative y equals negative 3x plus 10. There you go, you're right.
You're so smart, dude.
Good thing we shouldn't be skipping steps. There's a lesson for you, okay? Trying to do that in my head, so I drew my picture wrong, for sure. For sure. Okay, so I'm gonna substitute that into here. Okay, so I still got x squared plus 3x minus 10 squared equals 100. Okay? X squared, 3x times 3x is 9x squared. 3 times 10,
30.
negative 30, double it. Negative 60x, negative 10 squared, 100 equals 100. Correct?
Yeah.
Okay. Plus here, the hundreds are going to cancel each other. X squared plus 9x squared, 10x squared minus 60x equals 0. How do I solve that? 1x. I'm left with, or 10x. How about, let's pull out a 10x.
10x minus 6 and 1.
X minus 6 equals 0. So, so then what?
I don't know.
So either that term is 0 or that term is 0. So 10x equals 0, or, oh, well, you guys aren't terrible cameramen. Been off the screen the whole time. Good thing you guys don't work for Fox or KJazz or NBC or anything. Play would have been over. We're gonna get the touchdown here. Tell you a true story. Doing a game in New Mexico for ESPN. Utah, New Mexico. Utah lines up for the kickoff. Ball goes in the air. It's in the air, and the power goes out in the truck. Dead. It's pitch black in there. So now, of course, kills my computer, everything. It was literally because somebody had used the microwave and it killed the circuit. Wow. So we're trying to get cameras up as fast as we can. Meanwhile, Utah drives to the length of the field, and just before they scored the touchdown, I got my bug back up and I got the touchdown. We had like one camera working. So anyway.
So you still get recorded? It's recorded.
We got the touchdown recorded. We didn't get the kickoff.
So what if people watching
People watching went, technical difficulties, wonder what happened. Somebody plugged in the microwave. Anyway, x minus 6 equals 0, so therefore, x equals 0 or x equals 6. Okay, so I know that x equals 0, but now I've got to figure out what is this point, and x is 6. 1, 2, 3, 4, 5, 6. So it's probably going to pass about right here. This line is now wrong. It's going to go like that. So I've got to figure out what is this point, what is that point. How do you find those 2 points?
plug it in?
So we're going to plug them back into which equation? And plug it into here, right? Y equals?
Yeah.
So if x is 0, y equals
-10.
negative 10. So it crosses at 0, negative 10. So I got that point correct. Okay. So now I plug in the 6.
18 minus 10.
Y equals 18 minus 10, which equals 8. So this point is 6.
Yeah, it's supposed to be
Oh,
positive.
6, 8. Yeah, I guess I drew it wrong. It's supposed to be up there. 6, 8. 6, comma 8. Okay?
We have to graph it.
You don't have to, but I just wanted to explain to you what's going on. So it's equal at this point and at that point. Okay?
So what happened to the original line that we found? I mean, we found it to be y equals negative 2x minus 10.
Because that was a mistake.
Is
This is what it should have been. Y equals 3x minus 10.
That would be right.
So this equation's wrong. This is what the graph really looks like.
So the answer to that would be the 2 points.
The 2 points. So 0, negative 10, and 6, 8. Okay? Should we do another?
Yeah.
All right. How about,
Let's try elimination.
that's a good idea. How about 3x squared plus 2y equals 26, and 5x squared plus 7y equals 3. That did happen to me at a volleyball game at the University of Utah. We were in the 5th set, and some circuit got fried, and we never got the end of the game, and it was sad. And it was like a playoff game, too. It was terrible.
They let you keep your job?
It wasn't my fault. Yeah, I did keep my job. Okay, and you should see the circuit they showed us. It was totally melted. It was
Is the bottom one plus 7y?
plus 7y. I want to make sure I wrote that down right. 3x squared, 5x squared, 2y, 7y. Yes. Okay. So somebody wanted to use elimination. Who wanted to? Spencer, you want to take it over?
Yep.
Want to eliminate the x's or the y's?
Let's start with the x's.
Okay. How would you eliminate the x's?
So you times the top by -5.
You're not Spencer.
My bad. Sorry.
Yeah, do
Just got really excited.
Okay, do that. All right.
Bottom by 3.
And the bottom by 3. This is going to give me
So it's negative 15x
15x squared
plus, or minus
minus
10y.
10y equals.
That's a big
Ooh, that was a big number.
180.
No, it's not. It's about 100 and, let's say, 5 and 6 is 30.
Yeah, you're right.
It's 130. And it's negative.
5 times 30.
Check my math on that, but I think
It
that's
is
right.
1/3.
Okay? On the bottom one, we're going to get
With 36.
Squared
15x squared
plus
plus 21y equals
9.
9. Okay, that goes away. I'm going to get 11y equals negative 121. Divided by 11. Y equals negative 11. Okay, then what?
Plug it back in.
Plug it back in.
Let's do the bottom one. So
The bottom one,
5x squared plus
5x squared
7
plus 7 times negative 11 equals 3. So that's negative 77, so I'm going to add 77. 5x squared equals 80.
8.
No, 80.
80. 8.
8,
Come on.
80.
I put 9.
3 plus
It was
77.
88, 5 couldn't divide into it. So.
Wait, the top is 9.
What are you talking about? There's no 9s.
No, the very top.
Okay, we use this equation here.
Minus.
Okay? All right, divide by 5. X squared equals 16. How do I solve that?
Plug these two.
Square both sides. Square both sides.
X equals 4.
Use the square root of both sides. X equals what?
Plus or minus. Plus or minus 4.
Plus or minus 4. Don't forget that. Plus or minus 4. By the way, what are these two? What do they look like? They're both parabolas, correct? Okay. So your answers are, in this case, we've got a parabola that crosses each other twice, right? Okay. So the answers are plus or minus 4, comma, negative 11.
That's because you square.
Okay? So essentially what we're saying is plus 4
You have to
minus
use
4
Oh.
and negative 11.
I don't know why.
Negative 11. Okay, so they're going to cross here and here. They're both downward shaped parabolas. Okay? All right. They have a graph, and it looks something like this, just so you know. Here's one parabola. Here's the other parabola. That's where they cross. Okay, they cross at those 2 points here.
We're not gonna get asked about the graph, right?
Oh, no, I should. You guys, I know you hate graphing, but doesn't it help to understand what's going on?
Conceptually, test.
Makes it harder, I think. But that was getting some more points.
Example 3 says use the graphical method. But you know what? You guys suck at graphing so bad.
Let's
I'm not
try
gonna
it.
make you do that.
You're not. You're safe.
We gotta get better.
But I would like you to understand that. The problem is, when you do it graphically, you gotta have graph paper, and then you gotta be precise. So I'm not gonna worry about that. But, gosh, that was a nice short section.
Can you do the first problem you did again, but with the elimination method?
With the elimination method? Sure.
Would it work?
Should. You can tell me whether you think it's easier or harder.
You want us to write it as
Way harder.
I definitely think that substitution is the easier method on that one.
Do you want us to write it as like, y equals this, x equals this, or square the ordered pairs?
Ordered pair. I would like this in ordered pair.
That one. Or negative 11.
You could write it as plus or minus 4, negative 11, that would be fine.
For elimination, could you square the top equation?
You could, which one? Could you square?
The one that we're doing right now.
No, you want to square the bottom.
Yeah.
Or I mean.
No, you square the bottom.
Yeah, you can do that.
So can you square the bottom, so then therefore you
You
get
know
square
what?
minus.
That's horrible.
Yeah.
Because then you're gonna get X, Y terms, it's gonna be awful. I would not do it.
I would not do that.
So we're not gonna have to do anything like that
We
on
just do x
that?
plus y equals 10.
Well, the problem is, if you wanna square the bottom, that's what you wanna do, right?
Or no.
Let's show what happens. We're gonna square one
Square the
side.
top one.
I would get y by itself before you did that.
Yeah, that would be better.
So then you do
Because
x
you need
plus
at least
y.
have y
If you've got
squared.
Y by itself, just use substitution, but you could, you wanna do it that way?
Yeah, just square root of the
Okay, so
top.
we're gonna get, so Y equals 3x minus 10. Now we're gonna square it.
Essentially,
No, that's not what he's asking. He's asking, do the original problem, but it's,
The
to
top one.
eliminate,
square
he
root.
wants to square root the top, so it's x plus y equals 10.
Okay, you can't square root the top.
We can't, okay.
What you wanna do is you wanna say, oh, that becomes x plus y. No, it does not.
Oh, come on, yeah.
No.
No, it doesn't.
Please let it happen just this one time, honestly.
Okay, it doesn't work that way.
X squared plus y squared equals r squared, right?
X squared plus y squared equals r squared. That is true.
So like, I don't know, like, that's kind of like.
Yeah, this is, you do not wanna use the elimination method. It's impossible. I won't. I don't know. Well, I will say it's impossible. I don't know how to do it.
I can do it.
Okay? All right, so give me an extra 5 minutes to write your review. I'll try to do that for you. You just will get it there so that everyone doesn't have to do it on.
Yeah, you have to do it, okay. You're awesome. Awesome. Cool.
Okay? See y'all tomorrow. We'll review and then we'll take our test. And it will be much fun. It's going to cover logarithms and partial fractions. It's going to be a fun test.